Recording in progress. Record. Recording in progress.
Hey, do you hear me? All right, do you hear me? I'll just double check if the mic function is okay.
Yes, yes.
Thank you.
Form 4喺度嘅，我想教堂啊。
It's Form 4. Now, for the time being, I would like to remind you you're going to check the answer for this part. Now, this is question 2. Okay. Now, for those who still haven't done that, spend some time on it, and I would like to double check the attendance before it starts. Are you here? I can see your name.
Yes.
Yep, yes, thank you. Okay. Now to start with the lesson, okay, to start with the lesson, shall we welcome Ma Zihin to our class? All right, so question 2 on your page, on page 8 of your book. Now, could you please take a look on that? And I would like to check the answer with you. First of all, the acids. 大家聽明要？大家聽明要？Not here, right? So I better make the attendance record absent. Okay. 談字啊
Yes.
Give the names of exit A.
Sulfuric acid.
Sulfuric acid. How will you know?
Because it reacts with zinc and gives zinc sulfate. So I know the acid contain SO4.
Okay, so yes, that's right. So this is our logical deduction. You are going to check the zinc react with the acid to form a salt. So you know that the salt, the combination of the salt comprises two parts. Zinc sulfate is from zinc, while sulfate ion it must come from acid. So the acid itself must contain sulfate ion. So the acid containing sulfate ion is called dilute sulfuric acid. Gas B. Gas B. Gas B. Yeah. Lâm Minh Trấn. Gas B. Hydrogen gas. Hydrogen gas. So a reaction between metal and acid, dilute acid. So remember, dilute acid. This is a very important item. Dilute. Later on, while you go to book 2B and you will get to know more. It's not just hydrogen gas; it can be some other gas. From anyone who know? If I change the acid from dilute sulfuric acid to concentrated acid, I do the same action on metal, right? So what will be the gas form? It's not hydrogen.
Sulfur dioxide.
Yes, sulfur dioxide. So this is what we call it concentrated sulfuric acid. It's much different. It's because concentrated sulfuric acid is an oxidizing agent. So, which means that when you have a metal react with that acid, so it will form salt, sulfur dioxide, SO2, and also water. So this is what I would like to draw attention to this. So remember the use of the term dilute is very important. How about nitric acid? If I have it nitric acid, if I do the similar action on zinc, right? So the gas form is not sulfur dioxide. It will form what? Do you know? You may check on the web. It's so easy. They concentrated nitric acid and then come out zinc. You know it? Anyone can, if you can search on the web, tell me.
Nitrogen dioxide.
Yep, NO2. While so that is very problematic. If I change it to dilute nitric acid, so again, it's also an oxidizing agent. While the gas form is NO. Now, very special, right? So remember, that's why whenever you talk about the acid, it's not just telling me what is the nature of what is the chemical nature of the acid, but also the concentration. The concentration of the acid really affects the outcome of the reaction. How about gas C? Don't worry, for this part, you will know it in red dots. Okay, you will know it in red dots. How about gas C?謝依哲。
Carbon dioxide.
Yes, carbon dioxide. So the way to see the term is carbonate. Carbonate. So the carbonate react with acid, so they will form CO2 and water. Color solution D. 嚟入 this colorless solution D. So it's H2SO4. Now, if you find it difficult, that is the way to solve the problem. So you write down these two chemicals, and you may get a gas on the salts.
Sodium sulfate.
Yes, that's right. So this is how we figure out the question. Sodium sulfate. Okay, so you may get the salt here, sodium sulfate. So of course, remember you were asked to write down the chemical equations. Remember to balance the equation. The sodium sulfate. Now, you cannot write down the formula on here because you are asking for name. Now, black solid E and blue solution F. You can do it together. Choi, you can tell together what can it be?
I think black solid E, it should be copper, and so for the blue solution F, it should be copper 2 sulfate.
Yeah, copper 2 sulfate is correct, right? Because of what? The blue solution, it gives you a clue. A very important clue that there must be a presence of copper 2 ion in aqueous medium, which is blue. A very authentic situation for that. How about black solid E? Copper? Is it copper?
Copper 2 oxide.
Yes, copper 2 oxide seems a better choice because copper itself is not black. Okay, so copper 2 oxide is black. While the reaction, we call it as H2SO4, AQ, and copper 2 oxide. And you do the same tricks. Okay, so copper sulfate, the salt form is copper 2 sulfate. So you may find I highlight that, and together with H2O, that is the product. So what you need to do is to memorize those general questions. Metal with dilute acid, except dilute nitric acid. Okay, what we just refer to is dilute HCl and dilute H2SO4. Second is the metal carbonate or metal hydrogen carbonate with dilute acid. 3, it is the oxide and hydroxide, which reacts with dilute acid to form salts and water. So the final one, we call it as neutralization. Now, can you see that for B part, suggest a test will identify gas B. When asked to identify the certain gas, always give the test and the results. Test and the results. Shall we ask the newcomer, Martin?
係咪用嗰個 Poisson test？
Could you please elaborate more on the steps?
將一個 burning spit 擺落去個 test tube， 係個 test tube 係裝咗啲，即係呢個 gas B。如果將個 burning spit 擺入去，如果佢熄咗又有 port 一聲嘅話，就入面就係 hydrogen。
Burning spin test, Poisson test is commonly said, right? But the steps are you you should be highly aware of the proper steps. Okay. First of all, burning spin. Once I put it into the tester, you mean that you're going to put it into the tester?
Yes.
Into the tester. So what will happen if the gas inside is just H2? Okay, we'll put it inside burning split. So what will happen? Do you know?
嗰個 burning speed 啲火會熄咗。
Yes, they will pull off. Why? Why? Now go back to something. Just we are going to try to relink the concepts in the past and the present of fire triangle. So you know that 3 oxygen, fuel, and also high temperature. So in case if I put the burning splints directly into the gas tube already containing hydrogen, so what will happen here? It's not stopped by here. So what will happen to this? So no, do you have any oxygen inside? The answer is no. So of course it will not be the burning splint will be pulled off. But wait a minute, if it is pulled off, which means no high temperature, no oxygen, just fuel, will they produce a pop sound? Now, so actually, what is mean by pop sound? It's done by an explosion, right? A very small controlled explosion inside the tester. So if you want to produce an explosion, first of all, the reaction will happen. The reaction, what we call it as this, okay, the formation of water, okay, because you are going to have gas, and go back to solid, to liquid. There is a sudden change in gas pressure inside, so which will cause you a sound. So the proper way to do so, anyone who can help, how will you solve it? How you do the burning splint test or pop sound test properly?
Put on 將個 burning spin 擺喺個 test tube 個 mouth 嗰度。
Yes, put the burning spin near the mouth of a test tube, but not inside. So observation is, what's the observation?
如果有 hydrogen gas 就會有 pop sound。
Okay, if there is a pop sound. So what you say that if there is a hydrogen gas, it will give a pop sound. In other words, if you hear the pop sound, what's the gas? Can you can you figure out the difference between these two terms? If the gas are they the same? Are they carry the same meaning? Do they carry the same meaning?
唔一樣。
Yes. What is the difference? What's the difference? I can hear some idea, right? So what is the difference? Now, you just said so, right?
但係點講咧？佢俾人感覺好似即係兩個句子表達唔一樣嘅意思啊。
From the feeling, from the feeling that you know.
I think
Yeah.
the first sentence is more like a deduction of what the gas is, and then the second one is like saying that hydrogen is a necessary component for the pop sound to appear.
Now the first sentence, yes, that's right. The first sentence is deduction, 推論. But that deduction is based on a fact. Now, of course, the second statement is a situational question. If the gas is hydrogen, it gives a pop sound. So what is the reason for you to deduce that whenever a pop sound is heard, the gas is hydrogen? Can you get my point? So the second statement is just a factual description. If the gas is hydrogen, it gives a pop sound. A factual one. And deduction, which means that you treat the gas as unknown, and you do the burning splint test, you follow the procedure, and you will hear a pop sound, while you use these results to help you conclude that the unknown gas is hydrogen. But this sentence, this type of deduction should be based on one fact. What is that fact? What is the fact? What is that fact? What do you think?
The fact that it contains hydrogen.
It contains hydrogen. So why do you think that whenever it contains hydrogen, it gives a pop sound, the gas must be hydrogen, but not other gas? Can you get the way of what? 朱家元, what do you think? Whenever you said this statement is said to be correct, right? It should be based on one important fact. So what is that fact? In order to justify, to verify the statement must be correct. Anyone who can help?
The flame cannot burn in hydrogen.
The splints cannot burn in hydrogen. If the splint is burning but in hydrogen gas only, of course, there will be no explosion, right? There will be no mini explosion. Now I give you a hint. Now this one, can I use this statement to give a reason why whenever a pop sound is heard, the gas must be hydrogen? Can I use this statement? How many of you would think that this statement will help you make such conclusion? For those who think that it is yes, please put a tick. If not, a cross. Do it now. No. Somebody say no. No. Just 5 or 6. How about the others? No idea. No. Now try to elaborate. 陳永忠. Try to elaborate. Now, if you were the one, you judge it as incorrect, we are looking for something correct, right? So can you use one sentence to tell why that deduction must be correct? Yes, it's situational. Yes, that's right. But it should be based on one fact. What I say? I give you one hint. One statistical results. My hint. Anyone who can help? Anyone who can think of it? It's based on one statistical results, such that I can say this for sure. No. If the gas is hydrogen, it gives a pop sound. I give you another sentence. How about the other gas? If I have certain statements such like if the gas is some other gas, it also gives a pop sound. Do you know?
其他氣體唔會有個 pop sound，
Yes, so
所以呢度一定係 hydrogen。
yes, so the hydrogen is the only gas. So this is the statement which gives a pop sound in a burning splint test. So that's why, because of this statement, you will say this deduction. So you are going to think it in reverse. If the pop sound is heard, a gas must be hydrogen. Can you get my point? So of course, this statement conceptually is correct. But if you write down as a deduction, we will not write it like this way. Can you get my point? While you say if a pop sound is heard, the gas is hydrogen, is based on one fact. Among all other gases, right? Hydrogen is the only gas which gives a pop sound in a burning splint test. If you can prove it correctly, which means that whenever I would heard a pop sound in a burning splint test, I can say for sure that the gas is hydrogen. Can you get my point? So what it brings to our concept of the term chemical test. So chemical test is said to be a very suitable one when it gives a unique results. Unique, 獨特. Do you know the meaning of the term? UNIQUE, unique. So which means that there is only one gas which would have such behavior. And you can use these distinctive features, right, to help you get to know the gas, the nature of the gas. For those who understand what I've just said, okay, could you please put a thumbs up? If not, just simply across. You understand, right? You understand now?
可唔可以碌翻上去少少啊？
咩叫碌翻上去少少？
即係我想碌翻張嘢上去少少咯。
咩叫張嘢？
即係個課本係呢度上翻少少，再上翻。
係，唔該咧。
因為我想影一影相，唔該啊，唔該。
哦，好啊。Don't worry of capturing this photo or not, because you will have it in your video, right? I will also upload it in the YouTube channel. Okay, finish?
Okay, 唔該晒。
Yeah, finish. If all those are finished, we come to this. You understand? So you do the same tricks on carbon dioxide, right? If you are going to ask for what is to identify gas C, right? You use the proper chemical test, right? So we come to this 14.3, the role of water in exhibiting property of acid. Do you see it, right? So we would spend some time on seeing the video, right, to talk about the role of water in exhibiting the property of acid. So indeed, pure acid, what's mean by pure acid? Pure, which means 100%, right? So no other chemicals added that may be solid. If you talk about a organic acid having a large RMM, large relative molecular mass, we will say that we will say that this is a solid. How about liquid? For example, you talk about sulfuric acid, nitric acid, ethanoic acid is a liquid, or even it can be a gas, just like hydrogen chloride. So remember, this two is different. Hydrogen chloride means gas, while hydrochloric acid AQ, while it contains hydrogen chloride gas and water. Now, so while this one it is just 100% HCl gas, so this is different. So the slight change in writing the statement would really affect the concept behind. Of course, no need to mention its name. Okay, now, so citric acid or salicylic acid, you may find it as a white solid. Okay, white solid is very similar to sugar salt, right? But it will only perform its acidic property by having one thing. Okay, so I would like to share with you the video now. Sorry to say that. So this is the one. Now let me know if you can watch it and hear the sound clearly. Video has been watched. Tell me one important sentence about to conclude the experiment. Now we call your memory about the observation here. This is what you just saw it into the video. So what is the conclusion? Hear it.
Conclusion is the acid needs water to be acid.
Oh yes, that's right. So the water must be present for an acid to exhibit its typical property. So it is exactly this same sentence. But what is meant by the acid and then typical property? So the typical property of an acid, of course, we will call it as what? A type of acidic property. So what is said as an acidic property? What is said as an acidic property? So they are just record the memory of the last lesson. You may find its action on the litmus solution or litmus paper for convenience sake, we use dry blue litmus paper. Without water, now all of you please mark it down, without water and with water for these two cases. So water plays a role by showing the blue litmus paper red. Second is about the magnesium ribbon, and they would have to show the sign of a hydrogen gas form because the metal, they will react with dilute acid to form the salt and hydrogen gas. Do you still remember that sentence? This general word equation that you know in the last lesson. How about the last one? Sodium carbonate, so which agrees with our sentence about the metal carbonate, react with dilute acid to form salt, CO2, carbon dioxide, and water. Can you see that? So you may find that water plays a very important role in exhibiting the acid's acidic property. Without acid, even though I call it as the name as acid, it doesn't behave like an acid. You may find very strange, right? Isn't it? Even though I call it as an acid, it's not an acid. Yes, I can say so. Even though it's not an acid, I will not call it as acid. Now, so why is it like that? It's because of the following differences between solid and in aqueous solution. For solid and aqueous solution, you refer to the diagram. I would like to show you another video, right? It will help you better understand what is happening. Sorry to say that we need to wait.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
The strength of an acid refers to the extent that it dissociates into ions when dissolved in water. Strong acids dissociate nearly completely. Weak acids dissociate very slightly. Dissociation into ions means that when an acid, HA, dissolves in water, it transfers a proton to one of the water's lone electron pairs, and the acid an ion, A-, and a hydronium ion, H3O+.
Hey, Mr. Chin, I find it very strange. What is that? What is actually happening? So, water, can you spot for me water? Where is water? The second particle, can you see that? The first one particles, HA, is an acid. The second particle, before the arrow comes, is water. Water, isn't it the V shape? Yes, that's right, it is V shape. But did you realize we have got something very strange on the left-hand side? What is that? Very strange. Can you see that? What is that? Do you know what's that? No, no idea. Now, please watch and this will help better explain what will happen. Now, how about on the right-hand side? A-. Oh, so what's that? And H3O+. So please take a look on the nature, right, of the particles on the left-hand side and right-hand side is different. For the left-hand side, it is HA, water molecule, with two lone pair electrons. You find it on the left-hand side to form A-, the salt form of the acid, and H3O+, another ion. Okay, so it is hydronium ion, the hydrated hydrogen ion. The hydrogen ion surrounded by water. So, can you see that on the left-hand side and right-hand side, the particles, they are different? How different they are? Chan Yingzhen, do you know what is the difference between the particle on the left-hand side and right-hand side? I'll give you some hints. Do they have a charge on the left-hand side?
No.
No, it's just molecule. How about on the right-hand side?
They have charge.
Yeah, they have charge. So we would call this type of process are called the transformation of molecules to ion, uncharged to charged particle. We call it ionization or
Form.
dissociation.
The color change of the water oxygen will make it easier to follow in solution later. The key difference between strong and weak acid dissociation is the final concentration of hydronium ion in solution. Since proton transfer from a strong acid to water is nearly complete, the hydronium ion concentration is essentially the same as the original acid concentration. In contrast, proton transfer from a weak acid to water becomes balanced by proton transfer from hydronium ion to A-. So the final hydronium ion concentration is much less than the original acid concentration. Let's view acid dissociation at the molecular level and focus first on strong acids. The concentrated acid in the beaker consists primarily of acid molecules. As soon as they make contact with the water in the flask, proton transfer from HA to H2O occurs for virtually every acid molecule. Note the change from blue to red. Therefore, a strong acid solution consists of hydronium and A- ions in water and virtually no HA. It follows that the acid dissociation constant Ka for a strong acid is very large. Now the beaker contains a weak acid. As before, the moment the acid molecules make contact with the water, proton transfer from HA to H2O occurs. But in a very short time, proton transfer from hydronium ion to A- balances it and equilibrium is reached. Thus, a weak acid solution has a relatively high concentration of HA and very low concentrations of H3O+ and A-. Therefore, the acid dissociation constant is very small.
Now you may see the video will mainly talk about the different extents of the ionization. In water, you talk about different acids. So that's why we would call it as a strong acid. Perhaps I will do it in the next chapter as well.
麥提莎脆脆松露朱古力咁好味，總有理由送俾你。
阿 Sir，你嗰個 YouTube 有廣告啊，廣告 send 飛咗出嚟。
Yep, sorry. I would like to stop it. Oh, here. Thank you. Stop it. I see. Now, thank you. So it seems that water plays a role in doing this ionization. How? Now, first of all, do something basic. The first basic point is that if I want to, no matter you talk about a citric acid or hydrogen chloride to form hydrochloric acid, water plays a role in changing molecule, the acid molecule, which is uncharged, to its ions, okay, which has a charge. The process, what we call it as ionize or dissociate. Okay, you see the word dissociate and ionize. So you may find the term very often in university textbook. You would call it dissociation or dissociation constant. Indeed, if you want to study more about calculations. Of course, up to this moment, you need not do the calculations on this. But in Form 5, later on, yes. But so far, what you need to do is to take a look at the term ionization. Ionization, a process in which I turn molecules to ions. Okay. While I do such, what are they? Whatever acid it is, what are they in common is that we have got a common ion, which is hydrogen ion. Now, so if I got a hydrogen ion, it will help exhibit its acidic property. Can you get my point? By reacting with the hydrogen, the carbonate ion to the metal, and to turn the litmus paper red. So the graphical representation is that the HCl molecule, once it's dissolved in water, it will ionize to form a hydrogen ion and chloride ion here. Can you see that? This is charged. It's charged particles. Can you see that? It's charged particles. So that's why if I recall your a similar process while you talk about sulfuric acid and nitric acid, in which they will form hydrogen ions as a common ion. So you may say an acid is a compound in which it will produces hydrogen ion as the only positive ion when dissolved in water. While the term produces, we call that ionization. So the ionizes to form hydrogen ions. So could you please change the wording a little bit? While the acid itself, it is a covalent compound because whatever combination of the acid it is usually contain, they are all covalent compound. HCl, HNO3, H2SO4, even though you talk about organic acid. For example, in vinegar, we have got ethyl acid, CH3COOH, etc. Right? All those you may find it is just a molecular form. Okay, so as you watch from the video and you know that water plays a role, it seems like water they will have the lone pair electrons. It will help drive away the hydrogen atoms to form hydrogen ion, to form this very stable, more stable species. We call that hydroxynium ion or hydronium ion, H3O+. So that's why in your book, so for some instance, you may see this, or you may also see this, you talk about the same thing. It is the hydrated hydrogen ion. Hydrated, which means surrounded, the water molecule surrounding them. Okay, the water molecule surrounding them. So the surrounding the hydrogen ion. Okay, you get my point. So you go back to here. What is the role of water? It seems like water. What is happening? I want to make it more difficult to, more challenging to understand. We have got a minus. We have got a plus. So it will help what come here. Do you remember the video? What happened to it? So they would come and heat this part. Have you ever seen that it will hit this part? No. It will hit this part. And then what will be formed? You may have got a slight change in the distribution of electrons in the covalent bond. While the single covalent bond, you just remember, we have got one dot and cross. Okay, so we have got the lone pair bonding electrons going to the chloride, and leaving behind is what? H3O plus. So this is the chemical process we mentioned. Do you understand? Now the question comes, Mr. Chin. Now this process we call that ionization. Okay, do you understand? The lone pair electrons of water on oxygen atom in the water molecule, they would attack the hydrogen part of the acid molecule, and it seems like after heating, they will take away the hydrogen, right? But this time the hydrogen is no longer in the form of atom; it is ion. So that's why you would have H3O+. Now, so as like this equation. Questions? I'll take a look on this. A student mixed the solid sodium carbonate with phosphoric acid powder and then either added water to the mixture. So what happens to this? What we expect to observe? Explain. What you expect to observe? With water, some reaction will happen, right? So what is the observation? What is the action?
嗰個草酸會變咗 acid 先，跟住 react with 呢個 sodium carbonate。
So to form what? To form something that is also observable. What is observable?
Some bubble occur.
Yes, a bubble. The colorless gas bubbles are given out. So the reason is that water plays a role, right? When water is added, what will happen? First of all, oxalic acid dissolves. The next step, and its molecules, what happens to this? Acid molecule ionizes to produce what? Hydrogen ion. Of course, you may have another chemical. We call that oxalate ion. Oxalate ion is the acid salt form, but we focus on hydrogen ion. Hydrogen ion, they are responsible, okay, for showing the typical properties of an acid. Of a dilute acid. Okay, so for example, in this case, it will react with sodium carbonate to form CO2 gas. So that's why it matches. Why you will say that colorless CO2 gas to relate with the observation, right? Is that there is a reaction between what? Between the acid and the sodium carbonate. But why there is a reaction is because once the water is added, the oxalic acid dissolves in water and the molecules ionizes to form hydrogen ions. So whenever I got hydrogen ions, it will react with carbonate to form carbon dioxide. Do you understand? So you may find the water plays a very important role. But it comes to our concern. Now, Mr. Chin, do you mean that any hydrogen in the molecule would have to show its acidic property when I dissolve in water? The answer is no. You take a look on the word basicity of an acid. So each of the acid, not all hydrogen atoms will be ionized. The basicity is a definition which tells you the maximum number of hydrogen ions that can be produced by one molecule of the acid. So you need to spot which hydrogen atom is ionizable. For example, for HCl, so you may find that we call that monobasic acid, is because for each acid molecule ionized, they will have one hydrogen ions. So you may find this. So I would like to show you this diagram for H2SO4. So we call it dibasic acid. It's because once it dissolves in water, they will form two hydrogen ions. Phosphoric acid being tribasic acid. It's because once it's dissolved in water, per acid molecule, it produces three the hydrogen ions. So don't worry too much about these reversible sign, which means that the extent of ionization is not 100%. Okay, but for you, if you talk about H2SO4, if you talk about HCl, you may find the arrow being a single arrow instead of a double arrow. Now take a look on this. What do you know about the basicity of acid and the number of hydrogen found inside the acid molecule? Now you may find that it very strange, right? First of all, somewhat basic. Whenever I have got these red hydrogen, the basicity agrees with the number of hydrogen atoms inside. In other words, what does it mean? All hydrogen atoms are ionizable. All hydrogen atoms found inside those acids are ionizable. So what are they? Could you please seek for pattern? So it is a type of inorganic acid. Usually, can you see that? Inorganic acid. 無機酸. But for this, it is a type of organic acid. So you may find that we have got so many hydrogen here, but only one hydrogen is said to be ionized, which is this COOH, that H, but not that CH3. Do you realize the reason why? So you come to here. You should know you have to get to know the reason why. Okay, so very strange. Yeah, here. So you take a look on this. Ethane acid will have this structure. Recall your memory about the water. What will happen to this? For water, we have got lone pair electrons, and they would attack this. Okay, this hydrogen ion, but not this. Okay, why not? Now, is this because of the, do you know why? Do you know why? It's because of the chemical environment. So check for the term electronegativity. Now you type it on the web. Do you now search for me electronegativity? What is that? It is a measure of what, how attractive those atoms correspond to elements is when you're in a covalent bond or pulling the bonding electrons towards itself, right? Diffusing. Can you see the term? This one, electronegativity. So you may see this diagram, this trend, the number of it, will tell you how slightly negative it is while you're having a dative, while you have a simple covalent bond, single covalent bond. You will find fluorine is the most electronegative. So you may find this the highest number, 4.0, highest number. While for metal, are very low electronegativity, which means that they don't love to gain the electrons. In case we talk about covalent bond. Of course, it doesn't make sense. Okay, while you have got a combination of metal and non-metal, it will experience a very large difference in electronegativity. So we call it an ionic compound. However, while you talk about the bonding just like H2O, very strange. For hydrogen, you may find 2.1. Oxygen is 3.5. Right, the difference is quite moderate. It's quite a lot when you compare it with some other chemicals, just like hydrogen and carbon. Can you see that? hydrogen is 2.1, carbon is 2.5. So which means that if I put this into practice, I would like to show you here 2.1, 2.5, and what? Do you still remember? 2.1, 2.5, 3.5. 2.1, 2.5, 3.5. So you take a look. 2.1 on what? Hydrogen. 2.5, and then what? 2.5, 3.5, 3.5, 2.1. So that is the electronegativity. So in case if you consider this covalent bond, for example, it experienced a very large difference in electronegativity. That's why we will call it as delta plus and delta minus. And you see that the similar items that you may find it in water. Oh, can you see that? So that is the point. Now, how about this? 2.1, 2.5. Somebody may say that it's also that negative. It's positive, right? Delta positive. Then, however, that difference is not so obvious. Just like we have got a tug of war, these two classes, right? They are of comparable strength. The carbon here wins over the hydrogen a little bit. But if you want to talk about OH here on this side, you may find that we've got tug of war again. But this time the 3.5, this one's more powerful. So it seems that those bonding electrons, the one which is originally from hydrogen, it seems moving towards what? Oxygen side. So that's why you may also see a directional arrow like this. Well, the direction arrow, it will tell you what? It will tell you the higher tendency of having a more dense bonding electrons towards oxygen. That's why water surrounding those acid molecules, they will trigger the ionization of that hydrogen atom. Remember, the hydrogen atom is usually found in COOH, and that will happen. Can you get my point? COOH, then this will happen. So don't worry about this one, because now this is also help trigger that type of a pulling force. Can you see that? We've got one arrow and two arrows. They do all together. We'll collectively call it, it will help trigger the ionization. How about this? If I have got the structure of tartaric acid, it's a dibasic acid. Can you identify all ionizable hydrogen atoms? As said before, what you need to do is to check what? COOH. COOH. Can you see that? Now, not OH. So if you want to talk about ionizable hydrogen atoms, it's on here. Okay. Questions? Now, believe it or not, if you want to talk about citric acid, do you still remember the citric acid? Last time you talked about citric acid, right? Citric acid, citric acid, citric acid. Do you still remember citric acid? Citric acid, this one, right? Also citric acid. I would like to show you the formula of citric acid. Citric acid. Citric acid. Can you tell me the basicity of an acid? Citric acid. This one. What is the basicity of acid? It's also a tribasic acid. Can you see that? Tribasic acid. How? The one on the left hand side, the one on the right hand side, and also on the top. All those, they are just COOH. Can you see that?
我成日見唔到個 C 喎，但係個 C 喺邊啊
Where? Yes, good question. Where
我見唔到個 C。
你見唔到個 C 啊 ？Where is C? Where is C? The C is all the turning point of this structure. 轉角位. So you may find the structure of citric acid. How about this? If I change the formula to this, till you find it. Do you find this? It is the citric acid, right? On the left-hand side. Can you see that? All those, they are just turning point. So for simplicity's sake, they will draw this. They want to save some time on drawing the carbon and also some hydrogen. Now, why? Because those, they are not so reactive. So we focus on those reactive sites. And the turning point, as said before, it is carbon. Can you see that?
係咪真係所有起角嗰啲位都係 carbon？
Yes, that's right. Okay. Do you understand? So this is what I would like to share with you for today. And before we end up the lecture today, I would like to check understanding. I would like to check the understanding by having this reaction as well. I would like to show you this. Tell me what is the chemical principle found inside.
Tommy 火車世界喺世界錄影帶一盒 Tommy 立體大鐵橋套裝。Tommy 火車世界，希望號列車出發，分岔路轉彎。
想骨骼強健，咁樣撒點得㗎？飲康蓋斯，日日補充C加鈣，提升抵抗力，仲強化骨架。每日一撒好健康，康蓋斯。
Tell me, can you tell me what is that? What is the chemical principle? What is the chemical principle? I give you a hint. I give you a hint. 康蓋斯 the chemical component. Can anyone help? What is the chemical principle behind? Question 1.
係唔係嗰隻康蓋斯俾啲 base 即係吸咗啲 H 嘅 ions？
吸咗啲 H ion。哦 vitamin C is acid. I don't study biology. Sorry to say that for studying chemistry, you still need to know some concepts about biology. So sad. Good
係因為
approach.
有嗰個咩 sodium hydrogen carbonate 啊。
Yes, sodium hydrogen carbonate. Yes. What else? In vitamin C tablet, or we call it efflorescence tablet, what is containing inside? We've got acid. Yes, vitamin C is an acid. What is the acid? And what else? Indeed, okay, could you please, do you remember? Well, once I put Hongkong C inside water and colorless gas is formed. You know the gas is carbon dioxide, right? But besides vitamin C is an acid, once it dissolves in water, what will happen? We also have some lemon and orange flavor, right? What does lemon and orange flavor come from? And another acid. You call that 檸檬酸 citric acid, right? Citric acid, ascorbic acid, dissolve in water, what will happen? Okay, shall I hear one important word, which is start with the word I. Ionize. Ionize in water. So what will happen? Ionize is water to produce hydrogen ion. So hydrogen ions will then what? Hydrogen ions, they will show the acidic property by reacting with Hongkong C. What is the chemical? It's not sodium carbonate. It is sodium
hydrogen carbonate.
Yes, hydrogen carbonate to form carbon dioxide gas. So that's why the word SAR, which means effervescent tablet, FCC tablet. It is something about chemistry and daily life. FCC tablet, FICCY. Okay, I'll just stop it here, and we will leave the doing this ionic equation exercise by yourself, and I would like to check the answer in the next lesson. Okay, is that clear? Before you leave, me your level of understanding of today's lecture. And can I have could you please tell me what find it difficult to you before you leave? Any difficulty encountered? Tell me any difficult part. Write that you on here. Marks as well as any difficult part. Besides number, tell me what is difficult to you. Now, don't worry too much about ionic equation. I have also covered in Chem 1 lesson, and I've uploaded Chem 1 lesson video. You need to check the last about 15 minutes of the video. I would like to show you the video as well. Now, such that you can get the answer for 14.4. Any questions so far?
淺 Sir， 我都唔係好識分點樣係大 basic 同 tri basic 嗰個 part。
Di basic, tri basic. Okay, yes. Now, di basic and tri basic acid, which means, di basic 即係每粒 acid 入邊佢可以生產到幾多粒 hydronides？ 嗰啲叫 di basic 或者 tri basic acid 咯，大就2啦 ，tri 就係3啦。即係話佢可以最多生產到3粒。咁我使唔使理個相戰嘴啊？唔需要理嘅。咁佢話咧，佢可以嚟ionize 啊嘛。咁究竟佢可以 ionize 同埋最後係咪100% ionize 係兩樣嘢嚟嘅？咁所以咧，如果係 H2SO4、H3PO4 咧，直接就 check 翻佢有幾多 H 咧，就個答案就係㗎啦。咁你記住咧，就兩個可能性啦。第一個無機酸啦。咁有機酸咧，例如我頭先講嘅Citric Acid 啦、Citric Acid 啊呢啲等等咧，有機酸嘅。咁佢哋咧，我淨係 check 一個位嘅啫，就係 COOH 嗰啲 H 咧有幾多個，嗰個就係話俾你聽佢個 basicity 啦。咁點比啊？係一粒 molecule 入邊有幾多個 H 啊 ？OK， 咁譬如你講 Citric Acid 呢一個咧，個結構就係2個 COH 啦，所以我就話佢大 basic acid 啦。咁但係如果你好似頭先講 Citric Acid 嘅話咧 ，Citric Acid 係點㗎 ？Citric Acid 咧呢度係有3個 COH， 所以咧我嗌佢呢個叫做 tri basic acid 啦。記唔記得啊？即係喺呢幅圖上面嘅右手邊 COH 3個，咁左手邊個 OH 咧就唔係，記住係 COH 咯，得唔得？
哦 ，OK，
即係
明白晒。
呢個有幾多 H 都冇嘅，因為唔係所有嘅 H 咧都可以 ionize 嘅，只有 COH 嗰啲 H 先得嘅啫。仲冇嘢想講？冇。I'll be here. It's time to take a break. Thank you and goodbye.
拜拜拜拜。
Bye.
Goodbye.
拜拜。
拜
拜
拜。
拜拜，錢 Sir。
拜拜。
拜拜，錢 Sir。